Today we are going to learn sulfur system. Sulfur is known as polymorphism because sulfur will exist in four different phases such as sulfur rhombic, sulfur monoclinic and sulfur liquid and sulfur vapor. So sulfur is known as polymorphism, and here sulfur rhombic and sulfur monoclinic are two crystalline states of substances, and sulfur liquid is in liquid state and sulfur vapor is in gaseous state. So here these two crystalline states possesses different physical properties because these two are in solid form, but these two crystalline states possesses different physical properties. But sulfur rhombic is converted to sulfur monoclinic at particular temperature. Here at particular temperature sulfur rhombic is converted to sulfur monoclinic at particular temperature. That temperature is known as transition temperature. So this is phase diagram of sulfur system. This is very important, and today in this video we are going to study again three parts. One is significance of curves, and second one is significance of areas and triple point. So in this video we are going to study significance of curves. So first curve is AO curve. Here this is AO curve. This curve is known as sublimation curve of sulfur rhombic, which indicates the equilibrium between sulfur rhombic and sulfur vapor. So here we are explaining only about this curve. So this curve, left hand side sulfur rhombic solid in state, and right hand side here sulfur vapor. So this is gaseous state. So this curve is in between, means this is equilibrium between sulfur rhombic and sulfur vapor at each temperature. There is only one vapor pressure or vice versa. So when you apply the phase rule, so phase rule is F is equal to C minus P plus 2. So here composition is same, composition is sulfur, but here at this curve the phases are different. Here sulfur is in solid state and sulfur is in gaseous state. So here phases are different. So two phases and composition is 1. So F is equal to C minus P plus 2. So degree of freedom is 1. It means system is univariant along the curve AO. Then variation of vapor pressure, we can know that we come to know that the variation of vapor pressure with temperature by Clapeyron equation. Here this is Clapeyron equation. dP by dt is equal to delta Hs divided by T into Vg minus Vr. So here V means volume. So dP by dt. So change in pressure or variation in temperature pressure with respect to temperature. So this is Clapeyron equation. Delta Hs is nothing but molar heat of sublimation of sulfur rhombic. So molar heat of sublimation of sulfur rhombic. So this is first curve AO curve, and second curve is OB curve. OB curve is known as sublimation curve of sulfur monoclinic SM, which indicates, here this curve indicates equilibrium between sulfur monoclinic and sulfur vapor. So again same as AO. So here this is also one component system, means composition remains constant. So here you will get degree of freedom is 1, system is univariant along the curve OB. Here also the variable either temperature or pressure. So When you apply Clausius-Clapeyron equation, the equation we can write dp by dt is equal to delta hs by t into bracket vg minus vm, the variation of vapor pressure along the temperature. So here delta hs is molar heat of sublimation of sulfur monoclinic. So this is second curve, ob curve. And next one is be curve. This curve, be curve. So this curve is known as vapor pressure curve of sulfur. Vapor pressure curve of sulfur here, which indicates the equilibrium between sulfur liquid and sulfur vapor. So it indicates the equilibrium between, this curve indicates the equilibrium between sulfur liquid and sulfur vapor. So degree of freedom is 1 because composition is 1, phases are 2. So degree of freedom is 1. System is univariant along the curve BE. When we apply the Clausius-Clapeyron equation, we will get dP by dt is equal to delta HV divided by T into Vg minus VL. So this is about BE curve. This is about BE curve. And next curve is here BC curve. BC curve. So it is known as fusion curve of sulfur monoclinic. This is fusion curve of sulfur monoclinic of which indicates equilibrium between this curve. This is a curve BC curve. These curves indicate the equilibrium between sulfur monoclinic and sulfur liquid. So again degree of freedom is 1. F is equal to C minus P plus 2. So here in BC curve, F, C means composition. Composition is same, sulfur only. P means phases. Phases are 2. How? One is sulfur monoclinic, another one is sulfur liquid. So degree of freedom is 1. Next, when you apply the Clausius-Clapeyron equation, we will get dP by dt is equal to delta HF, because it is a fusion curve, delta HF by T into VL minus VM. So this is about BC curve. And here this is also one curve, CD curve. Next curve is CD curve. So it is known as fusion curve. This is also known as fusion curve of rhombic sulfur. This is fusion curve of rhombic sulfur, and it indicates the equilibrium between, here left hand side this is sulfur rhombic and right hand side sulfur liquid. So it indicates the equilibrium between sulfur rhombic and sulfur liquid. Again same, degree of freedom is 1, and this is also univariant along the curve CD. There is only one variable. Degree of freedom 1 means there is only one variable, either temperature or pressure. And next curve is OC curve. OC curve. It is known as transition curve of, which indicates, this is a transition curve of sulfur rhombic. This is a transition curve of sulfur rhombic, which indicates the equilibrium between sulfur rhombic and sulfur monoclinic. So this curve indicates equilibrium between sulfur rhombic and sulfur monoclinic at 95.6 degrees Celsius. We already studied that where the sulfur rhombic is converted to sulfur monoclinic. The sulfur rhombic is converted to sulfur monoclinic. That particular temperature is known as transition temperature at 95.6 degrees Celsius. This temperature is known as transition temperature. And next, when slowly temperature of rhombic sulfur is increased, Some molecules